Hello, everyone. Welcome back. We are up to lesson 7 of unit 5. No new lesson notes in this lesson, so we're going to go right ahead and get into the examples. So let f be the function given by f of x equals g squared. Number 1, write an equation for the function whose graph of f is translated 3 units left and up 5 units. So we're going to write the function notation first, okay? And then we'll write the actual equation. So we're going to do g of x equals f of x. So we are shifting 3 units left. So if you remember, when we're doing a horizontal shift, we have to do the opposite and it goes inside the parentheses. So 3 units left would normally be minus 3 because left is negative, okay? But we're going to do the opposite, which is plus 3, and we're going to put that inside the parentheses. So x plus 3 goes inside the parentheses. And then our vertical shift is up 5 units. So that one, we don't do the opposite, and we put that outside the parentheses. So that's going to be up 5 is going to be plus 5 outside the parentheses. So this is our function notation. Now what we're going to do is we're going to find the actual equation. Our actual equation of the original function was x squared. So f of x plus 3 means to replace x with x plus 3. So that's going to look something like this. So I replace x with x plus 3 and then tack on plus 5 at the end. So I end up with x plus 3 squared plus 5. So that is my equation for g of x. Okay. Number 2, what is the vertex of the graph of g? Explain how you know. So let's go graph this on Desmos. So that's going to be x plus 3 squared plus 5. The vertex, remember, is the high or low point of a parabola. So in this case, it'll be the low point, and it's negative 3, comma 5. So the vertex is negative 3, comma 5. And if you notice it, if you match that up with the original translation, okay, the original translation was 3 units left, and my x value of the vertex was negative 3, okay? And up 5 units, my original y value was 5. That is not a coincidence, okay? So for number 3, write an equation for a quadratic function h whose graph has a vertex at 1.5, 2.6. So 1.5, 2.6, okay, that's going to mean 1.5 units right, okay, and up 2.6 units. Okay, so when I write my function notation, what are they're calling this h? So h of x, and when I compare it to f of x, okay, 1.5 units right, I have to do the opposite of it, so that's going to be minus 1.5. Okay, opposite inside the parentheses. And then for the vertical one, I don't do the opposite and put that outside the parentheses. So plus 2.6. So f of x minus 1.5 plus 2.6, which means my equation is going to look something like this. So it's going to be x minus 1.5 squared plus 2.6. Okay. So for number 4, we're doing the same thing, except now first of all, we're opening downward. So we're opening downward, and my vertex is at 3.2, comma, negative 4.7. So that means 3.2 to the right and 4.7 down. Okay. So my function notation is going to be k of x equals, okay, 3.2 to the right. That's going to be f of x minus 3.2. And then minus 4.7. Because 4.7 down, we don't do the opposite, and we put that on the outside. Okay? So my function is going to be x minus 3.2 squared minus 4.7. But we're not done yet. And the reason why we're not done is this fact that it's opening downward. Okay? If I were to graph it as is, it's going to open upward. So to make it open downward, all I'm going to do is I'm just going to put a negative out here. So negative x minus 3.2 squared minus 4.7. That will create the vertex at the right place, but it will also make it open up downward. So this right here is my equation for number 4, and that is it for this lesson.